Hi everyone, welcome to the sales tutoring. This is my email address, and then in this video I'll be doing algebra chapter 1, and I'll be doing tutorial 37 of roots and polynomials. And then the tutorial goes on to say, find in modulus argument form and plot on the complex plane all the nth root of a. So I really don't want to call this tutorial 37 because I'm not gonna be doing this part. I won't be doing this part because actually my aim is to demonstrate how we can determine the roots of a complex number. So to remind you, before we work on our questions, remember that a is our complex number, and then we want to find the nth root of a. Okay, and then a being our complex number, r represent our modulus of a, and then this theta here represent the argument of a, and this term here is given as e to the power of 2 pi I, and we said that this is equals to 1. We said this in when we were working on Euler's formula. Okay, now I'm not gonna do the whole of the questions in tutorial 37. I'm gonna do B and C because I think the other ones, once you get these ones, the other ones will be simple to do on your own. Okay, now one last thing to remind you of is that we said that the modulus of a, which is r, we can find that by taking the square root of x squared plus y squared. Okay, where x is our real part and y is our imaginary part. Okay, and then we can determine our argument theta by saying y, the imaginary part, divided by the real part, and then from there we're gonna determine our theta. Okay, now starting with the first problem, which is problem B of tutorial 37. Our nth root is 4, and then we have our complex number as being 1 plus I. Note that having n being 4 means that we have 4 roots, so we're gonna have to determine the 4 roots of 1 plus I. Okay, now let's first determine the modulus of a. So that will be is equals to our x, which is the real part, is 1, so it will be 1 squared plus the imaginary part, which is equals to 1. Note that we don't put on I because I is no longer an imaginary part but somewhere it is called okay, I forgot the name, but here we put on the imaginary part, which is equals to 1, the coefficient of I, which is equals to 1. So we find that r is equals to square root of 2. Okay, now finding the argument of a, that will be tan of theta. Our argument is equals to y, which is equals to 1 divided by 1, and we find that theta is equals to pi over 4. Okay, so let's work on let's write now we're gonna write that we're gonna write n, we're gonna write this thing here, the whole of this thing, in this form. We're gonna write it in this form here we're gonna write in this form. Okay, now we're gonna have our a, which is equals to 1 plus I raised to the power of 1 over 4, and this is equals to our r, which is equal to square root of 2 e to the power of our argument is pi over 4 I plus 2 pi I k. Okay, and then we're gonna have the whole everything here raised to the 1/4 power. Okay, now simplifying further, we found that this is equals to square root of 2 raised to the 1/4 e to the power of pi I over 16, and this is plus pi I k over 2. I hope you do not get lost here, because I'm just multiplying everything in the bracket by 1/4. So this is what I got. The 4 multiplied by 4, I got 16, and then 4 divided by 2 pi I k, I got pi I k over 2. Okay, now this is we cannot go any further beyond this. Okay, so what is left for us is to give different successive values of k to determine our roots. Okay, so let's say when k is equal to 0, this gives us we can say 2 to the power of 1 over 8. Okay, this is 8. Okay, let me write it. 2 to the power of 1 over 8 e, and then we're gonna have pi I over 16. This is e raised to the pi I over 16. Okay, this is our first root when k is equals to 0. Now going on, when we're gonna get the value when k is given by -1. When k is equals to -1, that gives us 2 to the power of 1 over 8. Please take note, this is 1 over 8. Okay, it's not a dot. It's not a dot. I'm wondering why I'm not writing it well. Okay, let's bring it here to have 2 to the power 1 over 8. Okay, this is much better. And then we're gonna have e. Okay, when we substitute k here to be equals to -1, note that we're gonna have 1/16 pi I minus pi I over 2. So when we have to do that, we're gonna end up having something like -7. I think we're gonna have -7 pi I over 16. Yeah, if I'm not mistaken, this is what we're gonna have as our second root. And then our third root, let it be when k is equals to 1, and then when k is equals to 1, it gives us 2 to the power 1 over 8 e to the power of 9 pi I over 16. When we substitute k here, when we substitute k as 1, this is what we get. Okay, and then our last root, let's take when k is equals to 2, and that gives us 2 to the power 1 over 8, and then e to the power of okay, let's say pi 1 over 16 plus 1 over 16 plus 1, we get 17 over 16 pi I. Okay, so this is our roots, the whole of this thing. Note that this one, when k is -1, this is the root for when k is -1. And then yeah, this is all that you have to do when required to find the roots, not when required to draw on the complex plane. Note that I told you at the beginning of this video that I won't be covering the part of drawing. Okay, so my next question, I will be doing question C of of total of 37 prime. So that question it goes on to say so our n there is equals to 3, and our complex number a is given by minus 2 plus 2i. Okay, so let's find the modulus of a. So modulus of a is equals to 2 squared plus 2 squared. So we find that to be equals to square root of 8. Okay, and then the argument of a tan theta is equals to minus 1. We find theta to be equals to minus pi over 4. Okay, but this is the same, this angle here is the same as theta, which is equals to minus pi over 4 plus, okay, this is supposed to be plus, okay, sorry about that. Theta is equals to minus pi over 4 plus pi. This is because the graph of tangent repeats itself after pi. Okay, so the angle, this one is the same as what we get as being 3 pi over 4. So this is our argument. Okay, now writing that as minus 2 plus 2i raised to the 1/3 is given as square root of 8 e to the 3 pi I over 4 plus, and that is plus 2 pi I k, and the whole of this stuff in here is raised to 1/3 because our n is 3, so raised to 1/3. Okay, you can further simplify this to be okay, let me write it here, to be 2 to the 3 over 2, 2 to the power of 3 over 2, and then because we multiply everything in here by 1/3, so we're gonna multiply this by 1 over 3, and then e to the power of, if you have to multiply 3, if you have to multiply 3 here, this 1/3 by this thing here, we're gonna have pi I over 4 plus multiply this 1/3 by this thing here, we're gonna get 2 pi I k over 3. Okay, okay, so we have this, so this first simplifies to 2 to the power of 1 over 2 e to the power of pi over 4i plus 2 pi I k over 3. Okay, this is the first that we can simplify, and then what we have to do is just to substitute the various values of k. So remember, and that is something that I won't do, you have to substitute various values of k which are successive. So I'm advising you to use 0, 0, 1 and minus 1. So when you do that, substituting those values and putting them here, substituting these values here, you're gonna get the roots of this complex number. I'm giving you 3 roots because we want to find the third root, like one third root of this complex number. So substitute these things here, there, and then get the roots of our complex number, just like we did with the first example. Okay, thank you for watching. Check out the next videos where I'll be doing the next tutorial questions, and if ever you find any problem, don't forget to just go back to the beginning of the video. I gave you my email address. You can send me an email and then I'll explain this much easier. Okay, thank you for watching.